So let's take a look at one of these rewind problems just to remind ourselves how we're doing these. I'm going to take a look at 2. So we've got 2d plus 21 is less than or equal to 11. The first thing I need to get rid of here to isolate the d is the 21. So I subtract 21 from both sides, and I end up with 2d is less than or equal to 10, and it's a negative 10 because the 21 is negative and it's bigger. So now I want to go and I want to divide by 2. Divide by 2. Is my sign going to flip here? No, my sign's not going to flip here because I'm not dividing by a negative. I'm dividing by a positive 2. Yes, the 10 is negative, but the 2 is not, and that's what I'm dividing by. So that's what tells you that you need to flip your sign. So I'm going to be left with d is less than or equal to negative 5. When I go to graph that, I only need to put the negative 5 on the number line. That's all I really care about. If you want to put other numbers, you can. You can put a negative 6. You can put a negative 4, whatever you want to put. Then I'm going to put a closed circle at negative 5. And since its d is less than negative 5, I'm going to highlight the line going that way. So d is less than negative 5 or equal to it, which is why my circle is closed. All right, today we are going to talk about how to do these problems when they have variables on multiple sides. So in the case of the first one, we have 1x. I'm going to put the 1 in here as a reminder to myself that I have some x's there. I'm going to move this stuff down a little bit so we have a little bit more room to work with. All right, so I've got my 1x is less than 3x plus 8. So when I have a variable on both sides, think back to when we did equations with variables on both sides, and you've got to collect your variables, which means I want to combine all my like terms and get them over onto one side. So usually I would want to subtract the bigger one, the smaller one, but if I subtract the smaller one here, I'd be subtracting the 1x, and I don't want to do that because then that's going to give me nothing on the left side. So instead, I'm going to subtract the 3x from both sides. And remember that if you draw that invisible wall, if you subtract the 3x on the right side, then you have to do it on the left side of the wall. So again, I find that that's really helpful for people that forget where they need to subtract or add or where they need to do their inverse operations. So on the right side, that's going to cancel out, and I'm going to be left with 1 minus 3x, which is negative 2x, is less than 8. The next thing I'm going to do is divide by negative 2 on both sides. As soon as I write divided by a negative, which I just did right there, I'm going to flip my inequality sign. So my less than sign is now a greater than sign. I don't want to forget that when I divide by a negative, I have to flip my sign. If I don't write it on there, then I'm going to forget it. So I'm going to cancel out those negative 2's on the left side, and I'm left with just x. And on the right side, 8 divided by negative 2 is negative 4. So I end up with x is greater than negative 4. So I'm going to go ahead and put a circle, and then I'm going to say x is greater than negative 4. So again, the key things to remember there, I need to get my variables on one side, so I need to collect all my variables on one side. I prefer to have the variable on the left side. I like having the variable on the left side better, so we moved over the 3x, and then we ended up dividing by a negative, and when you divide by a negative, you've got to flip your sign. Okay, let's take a look at this second one. So in this second one, I've got 6x minus 1 is less than or equal to 3.5x plus 4. Again, I like my variables on the left side better, so I'm going to move this 3.5x over to this side. I subtract it from the 6x because those are my like terms. Remember, I can only do something if they're like terms. Otherwise, I'd be stuck. I couldn't do anything. But I can subtract those because they both have an x, and neither of them have an exponent except 1. So when I subtract that on the right side, this cancels out, and all I'm left with is 4. I still have this minus 1, and then I just do 6 minus 3.5. That would look like this if I were to write it out. Borrow from the 6 becomes a 5, and I end up with 2.5x minus 1. Now I'm going to go ahead and isolate the x because I've collected all my x's on one side. So now I'm ready to isolate. And to isolate, first I want to add 1. That goes away, and I'm left with 5. And on the left side, I have 2.5x. To get rid of that 2.5, I want to divide on both sides. It's a positive, so my sign stays the same. These cancel out, and I'm left with x is less than 2, because 2.5 goes into 5 twice. So when I go to graph that, I put my open circle or closed circle. It's a closed circle because it's got that equal to symbol underneath it, and it's x is less than, so my arrow is going to go this way. X is less than negative, or x is less than or equal to 2. All right, let's try one more. We've got to simplify before solving here, and we're going to simplify here by doing the distributive property, which is going to give us 6 minus 6x is less than or equal to 3x. So to isolate that x, I've got to collect terms first. I prefer to have my variable on the left side, but it doesn't really make sense to do that here because then we'd end up with negatives and zeros that we don't really want to deal with. So instead, I'm going to move over the 6x. This one is going to go away, and I'm left with 6. 3 plus 6 is going to give me 9x. To finish this, I'm going to divide by 9. Divided by 9, divided by 9. 6/9 is a fraction. I can reduce it to 2 over 3. And these 9s cancel out, so I have x is greater than or equal to 2/3, or 2/3 is less than or equal to x. So that means at 2/3, I'm going to put a closed circle. 2/3 on a number line would be between the 0 and the 1. So I'm going to put a closed circle right here. And then this is telling me that x, the bigger side is facing x, so x is bigger than everything than 2/3, so my arrow is going to go this way. X is bigger. All the stuff bigger than 2/3, so my arrow goes to the right. You can check yourself by plugging in one of the numbers that's highlighted. So for instance, like 6 right here. 6 is under the red line, so if we plug that in, 2/3 less than or equal to 6. And that's true. 2/3 is less than or equal to 6, so then that means my arrow is going the right way. That's a good way to check yourself if you're not sure if you put your arrow the right way. All right. This one has a bunch of decimals in it, but that doesn't mean it's scary. That doesn't mean we can't do anything with it. We operate just the same way. We still want to collect our x's. In this case, which x do I want to move? I'm going to move this one because it's negative, and if I move it, it becomes positive, which is a lot nicer to deal with. So again, even though I might rather have my variable on the left side, it's easier to deal with if I move it and make it positive. So I'm going to do that. It cancels out here, and I'm left with 0.9 is greater than or equal to 1.8x. To finish this off, I'm going to divide by 1.8, divide by 1.8, and I end up with, let me move this down so I have a little more room. I end up with 1/2 is greater than or equal to x, okay? Or 0.5 is greater than or equal to x. Whichever way you prefer to think about it, they mean the same thing. So I'm going to put my closed circle at 0.5, and the smaller side of the symbol is facing the x, so x is less than 0.5, which means my arrow is going to go this way. Remember, if your variable is on the right side, you draw your arrow the opposite way of the way the inequality sign is pointing. So since this inequality sign is pointing to the right, but my variable is on the right, I actually am going to go to the left. That's another kind of trick way to remember which way to go. All right, so go ahead and go try these 6. Okay, let's take a look at this one. Just as a reminder, what's going to happen when we do this one? This is an equation. These are two equations. Let's go through these and see what happens. So on the left side, I want to distribute, and I get 3x plus 21 equals 3x plus 21. If I subtract my 21s, I get 3x equals 3x. And whenever I have something that's true, like 3x equals 3x, that means it is called all reals, or all real solutions. So when I have identical equations on both sides, or when my variables disappear and I'm left with something true, that means I have all real solutions. Remember, these are these kind of two like tricky things that we talked about. So on this side, or I'm sorry, in this problem, I'm going to distribute on both sides. And I end up with 8x plus 20 equals 8x plus 6. If I subtract my 8x's from both sides, I get 20 equals 6. That's not true. That isn't true. So if that's not true, then that means that's a no solution. That is a no solution, which means there's no variable or value of that variable that could satisfy that equation. So there's nothing you could plug in for x that's going to make that work. As opposed to all reals, which means no matter what you plug in for x, that's always going to work. So does anybody have a guess on what happens if a situation like that occurs in an inequality? So let's take a look at number 1. Let's take a look at number 1. If I subtract my x, I end up with 5 is greater than or equal to 3. Is that true? That is not true. No, that is not true. 5 is not greater than 3. If it's not true, that means that's a no solution. So there's nothing you can plug in there that's going to make that inequality true. There's no such number. So can you graph no solution? No, just be a blank number line. There's nothing on it because there's no possible solution. Let's take a look at this one. If I get rid of my x's, so those go away, and I'm left with 6 is less than 5. So is that true or not true? That is not true. 6 is not less than 5, so that is a no solution. What do you think would happen if it were like this? All right, and we do the same thing here. We're going to subtract our 2's, subtract our 2x, and I end up with 6 is greater than 5. In this case, if 6 is greater than 5, that's true, so that would be an all real solutions, which means if I want to put that on a number line, I'm essentially just coloring in my entire number line. Because no matter what you plug in for x, it's going to be true every single time. So every single time that will be true. That's called an identity. That means no matter what you have for x, everything is true. All reals is a fine answer for that. So you can put all real solutions. You can draw a number line and color the whole thing in. With a no solution, you can't draw a number line. There's nothing to put on it. All right, so go ahead and try these 5. If you can graph them, do. If you cannot, you don't need to.